Everyone, in this video, we're going to look at the smart home microbits again. This is project 4 of our 5 initial intro projects, and it's called the auto wardrobe. If you're not familiar with the term wardrobe, it's a fancy way of saying like a standing closet. Okay, so if you don't have a wardrobe at home, something that's standing almost like a larger piece of furniture, and you have a closet, just imagine an automatic closet. Okay, so we're going to be looking at sort of having a door sensor and some lights change based on our inputs. Okay, so you can imagine opening it and the lights turn on. And then you can pick out your clothes. Sorry, I sort of forgot where I was going with that. So again, remember, start function starts off our program. Once the start function has completed, we enter our forever loop, our actual main program, and that's where all of our thinking is going to go. So let's see what's in start. Oh, there's quite a bit in here compared to future projects or past projects we've done. And the future project, the water level detector, you're going to see there's nothing in the start loop. Okay, so it can be all or nothing or a few things. It's never really a set idea. It really depends on what you're trying to do. So in the auto wardrobe, we're going to start by setting a button to pull up. We're going to talk about what pull up means in the future classes. But what you need to know right now is that it's an input. It's a button that can be pressed and toggled on or off. Okay, true or false. And we're going to use pull up. That has to do with the resistors we have available to ourselves. And we haven't gotten into that yet. So let's just ignore it. Next, we're going to set a variable door. Okay, so a new variable door, and we're going to set it to false, meaning it's closed. And that's important because that'll allow us to figure out our state. Is our door open or closed later on? And then, just like our first project, we're going to set a new LED, this time on output pin 1. And that's going to be a nice bright white light so that we can easily see what's inside our closet, our wardrobe. Then we're going to exit and go into our forever loop and see what we have to do. So has the button been pressed? Okay, so imagine a button on the outside that you can sort of walk up to and press. And if the button has been pressed, yes, that means it's going to go low. Okay, and if the button has been not pressed, okay, so it's still just sort of there, that's high. We're referring back to this idea of pull up. So if the button has been pressed, what do we want to do? Well, we want to set the door to true. We want to say, okay, yeah, door is open. And if the door is true, we're going to ask a second question. It's going to have a yes and no statement. On a yes, we're going to set our LED to white, turn it on, and we're going to set our servo to 0 degrees. That'll cause the door to move, and then we'll return. However, if the door is not true, so false, and we accidentally got in here without setting the variable, we're going to have a backup statement for ourselves. And if the door is not true, okay, so if our variable door is not true, so it's false, meaning it's closed, we're going to set the LED to black, which just means off, and set the servo to 180 degrees, which will return the door to closed. Okay. If the button is not pressed, well, pretty simple, we just return. Okay, so I went through this one a little fast. You can watch the video a second time or slow it down using your YouTube controls. But in a nutshell, we're just asking two simple questions. Has the button been pressed? And if the door is open or closed. If the button has been pressed and the door is set to true, we're going to turn on our lights and open the door. However, the next time we press that button, the door is no longer going to be true. It's going to be false, and we're going to turn ourselves around and close the door. Okay, so that's sort of like a conditional Boolean flip again, and we'll talk more about it in future classes. And when you start coding this and start looking at the code, this program is actually a lot smaller than what this logic system looks like, and it'll make a little bit more sense when you see it coded and working. Okay, hopefully this video helps. Hopefully I didn't misconstrue one of these concepts here, and if I did, I'm sorry, but please make sure you ask questions in class. Thanks.